the final day of Scala Days, and to my talk, Types versus Tests. I'm Amanda Laucher, or some of you may know me as Pandemonial on Twitter. And so I'll just go ahead and jump right in. I find myself quite often in situations where I'm arguing this types versus test, two sides of the coin sort of argument. Generally, when I'm hanging out at home, or when I have friends over, or when I go out to the bars, this is a conversation that often comes up. So one of two things generally happens when this conversation comes up. First of all, the people who have no idea what I'm talking about tend to sleep like a baby. They don't care at all. The people who know what I'm talking about are even worse. They're the scary ones because they have strong opinions. This topic tends to make people have very strong opinions. So what I'm hoping to do with this session is to not make you guys come after me in this manner, but hopefully reduce some of the need to do this. Something that's really popular in groups who are really passionate about types or tests is something called intersubjectivity. And what this is a language where we use vocabulary that tend to form a community. Monads, parametricity. You guys have heard these words. How do they make you feel? Scared? Kind of like you're at war? What intersubjectivity is it's this concept of you creating a community around the vocabulary that has this unwanted effect of isolating people. If you don't know the vocabulary, it can be very scary and very daunting to become a part of the community. So people are pushed away. So I'm hoping that we can all, as a group, understand what intersubjectivity is and kind of fight against it. Fight against the idea that people can't be part of our community because we're going to use these words that are going to make them not understand. So coming into this session, I had a couple of assumptions, and I think it's pretty safe with this group. First, I expect you've all used the REPL in one language or another. Scala has a great one, so my guess is you have. And I also have the expectation that you understand that some languages are better at doing types and some languages are better at doing testing. Languages are not created equal. Type systems are not created equal. Also, code is more often read than it is written. You write it once, plus lots and lots of refactoring, but then you spend a lot of time reading it. You, 6 months from now, probably isn't going to like you today with the code that you've written, regardless of how great it's been. So we really need to strive to make sure that our code is very readable. I also have this expectation that you're all craftsmen, which is probably why you're at a conference to begin with. You've all paid good money, or your companies have paid good money for you to come and really learn your craft. Okay, so where'd I get started from? This all took place over several years. This is a project that I've been working on for quite some time. And so I used to work for a company called ThoughtWorks, and when I started working for ThoughtWorks, I was doing lots and lots of testing, and I was telling everybody that TDD is the only way. TDD, TDD, TDD. You can't write code without tests first, because if you do, you're evil. So a quote from Martin Fowler, when in doubt, create a type. A quote from Yaron Minsky, make illegal states unrepresentable. He obviously cares a lot about types. He's a big old camel guy at Jane Street. Then there's this guy, Michael Feathers, who wrote a book called Working Effectively with Legacy Code. And so he describes legacy code as any code base without a full test suite. Now he goes on to talk about designing his code with the type signatures first. Stu Halloway. Stu Halloway is the guy who runs a company called Cognitech. It's the company that sponsors Rich Hickey and Clojure. And so he said 5 years ago, maybe 6 years ago at this point, that in 5 years we'll view compilation as the weakest form of unit testing. I haven't followed up with him to say, how do you feel about that today? My thought is he's probably overestimated at best. Okay, and then Jay Fields is a good friend who just wrote a book called Working Effectively with Unit Tests. And he says, given a good enough test suite, the value of a type system just isn't there. Okay, and then of course, back in the day, Ruby and Rails was like the biggest thing ever, and DHH came out and said TDD is dead. In fact, writing testable code actually ruins your design. So I start to think about this, and I think about Ruby as a language and the fact that you're not thinking types with Ruby, and you're not thinking tests with Ruby, and that scares the crap out of me. So if you go online, anybody who's been online, anybody who's read Reddit for sure knows that there are these zealots who say, Haskell all the things. In fact, I think Martin said the other day something about writing Scala to be the Haskellator, to make everybody want to write Haskell. So being bombarded by these people who say Haskell all the things or don't bother, right? If you can't write it in Haskell, if you're not making sure that you've thought about the types in advance and that if it compiles it works, then you shouldn't be writing code at all. You're not smart enough. So that definitely like pushed me away from that idea as well. So okay, where am I coming from with all of this? When I talk about types, I'm talking about abstractions. And what's scary to a lot of people is that when they think abstraction, you think a more general way to write your code. You want to be able to generalize. Well, when I talk about types, I'm talking about being more specific. And actually, if you think about great type systems, you think they may have prevented this guy from getting in this predicament. Obviously, this tortoise was invited to a garden party, and he was trying to decide which shoes to wear, and nobody told him that Crocs were completely out of fashion for a party. So he had an intent when he went into this. He had an idea of what he wanted to get out of this. But the type system was he was thinking in generalities, he wasn't thinking in specifics, and so he got himself in this predicament. Okay, so who's heard of the Curry-Howard isomorphism? Who's read this book? So it's 273 pages of kind of thick, dense material that makes it really hard to understand the concept that or that code and logic are one and the same. Correlating code to logic is something that people who are interested in type systems are trying to do. So that should bring to your mind something to this effect. I'll give you a second to read it. And so what's the problem with thinking about code and logic? What's the problem with that correlation? The problem is that we're generally very bad at logic, right? Like when we talk about something and we say, oh, that's logical, generally we don't mean that it's logical. We don't think in the mathematical sense of logic. And you know who else doesn't? Our clients. When I'm working with clients, they'll tell me all of these requirements that when you add them all together, they don't actually work logically. And so type systems tend to pull out those faults. When that comes out because you're writing well-typed code, that's a win. I think that's a huge win because it gives us the ability to have that conversation. So the problem of false logic makes a lot of people hate type systems. So I'd like for you for a second to think about this statement. Think about this slide. The type signature is a theorem, and the function definition is a proof. When I started looking at my code this way, it completely blew my mind and changed everything I did. A type signature is a theorem, and the function definition is the proof. If you're thinking about your code and you're thinking about logic in the mathematical sense, this will change the way you write code. Okay, so types. What do types do? They reduce bugs. They make code run faster. Who in here writes languages? Okay, so most people know that that isn't actually happening today, but it could. The ability is there. They define interfaces. Type checkers check compliance. And I think most importantly, they document a model. They document an intention. Ooh. They prevent copy-paste errors. They document your model. So the problem with models, however, is that they tend to leave out these little pesky little things that involve reality, right? When you're talking to your client and you're told what you're trying to build, they'll define this perfect little house and they'll put it into perspective that, wrap it up in a nice little box, put a bow on it, and it's this. But what they actually wanted and what you're actually going to build is this. So the problem with the model is that you need to be able to throw it away. So there are a lot of people out there who say, oh, I can't use type systems because if I do, then I can't change my model. Well, I tend to think the ability to throw away your model is the most important thing when you're starting to design an application with a client. If you can't throw away your model, then you're stuck. And I tend to think that if you have a ton of tests that are defining your model as opposed to the types, you get into some real binds where you end up deleting all of your tests, throwing them away because you changed your design to a point where your test will no longer pass. Who here has the problem where they write tests that they end up having to throw away if they write them too early? Yeah, same here. I've had conversations with people over and over again who say, oh, you're just writing the wrong types of tests. And so I did an experiment that I'll talk about in a minute that actually I sat with people and said, okay, well, just show me what I'm doing wrong. If I'm writing the wrong types of tests and they should continue to pass even though I've changed my model, please show me. And it turned out that wasn't the case. I think everybody's kind of in the same position. Okay, so people want to test 100% of their code. 100% test coverage, 100% test coverage. I used to say this all the time at ThoughtWorks. This was a big deal to say, if you're not writing tests, if you can't test 100% of your code, then there's something wrong with your model. But now, I'm talking to people who say, I don't write the type of code that tests, or that types could have prevented the errors I'd get. What's wrong with this? Okay, some people are awake. So I'm not writing the types of code that will be prevented by stringly typed programming. My type checker's not going to get that. But what are tests good for? Okay, so I just threw up the same stuff that types are doing to say, okay, if these are two sides of the same coin, are they really doing the same thing? Okay, well, tests will never make your code run faster because it's not something that you're not running them in a way that could make your test run faster when it's being run in production. They don't really define interfaces. But what they do is test logic. This is the client logic, the false logic sometimes, the stuff that's not really mathematical. The stuff you can't prove with math, you should be able to prove with tests. Okay, so types of testing. Functional tests. These are these really high-level tests that prove that your system does what your client wanted it to do in the first place. Property-based testing goes way deeper, and it allows you to test properties of your system. And you can even generate them. And who's used Quick Check or something similar to it? Scala check? Yep. And I'll talk about that in a minute. Unit tests, this is what people are talking about when they say TDD. And if you TDD your code, you shouldn't really need to have a type system or a type checker. And then REPL tests. At the same time that I was doing some of the experiments that I'm going to talk about, there was this idea that all you have to do is build your code in a REPL and then pop it into production. Right? REPL-based testing, REPL-driven development became a thing. And that's great. I mean, it helps you to design your code, but what it doesn't give you is the ability to run those tests later if you've changed something to see if you've broken anything that you had already written. But I think REPL tests help you to design your code, and they're extremely valuable. But I start with this question of, how do I know I've written the right tests? If I can't prove that my tests are correct, how can I prove that the code that I've tested is correct? And this starts to become this chicken and egg problem that really gets to my core and makes me think, what's going on with all this stuff? We've got TDD, we've got FP, we've got types. And at the time, I was going out and telling all my clients, you need to be TDDing because that's what Martin Fowler said, right? Or that's what the Ruby community had said for a long time. And I think a lot of people here, who here TDDs today? Who TDDs their Scala into functional design, well-typed functional design? Is it because you haven't tried? Or the vast majority of you has said, not me. And so I came at this from the perspective of I hadn't, and I don't really know what it means to, and can you? And so what I did is I got a whole bunch of people together in Chicago, and I said, okay, guys, am I just being stupid here? And sometimes it's kind of nice to come at things from this angle of, am I just really stupid? Because then you can ask people what their thoughts are and have no reason to feel like you're any less than anybody else when they say, oh, wait, yeah, I've been thinking about that too. And so Paul Snively, the guy on the top left, he and I have done a bunch of work and experiments to figure out, is there a way that you can TDD to FP and well-tested, well-typed code? And you'll see Dean Wampler is in this list as well. He's actually talking right now. He's an amazing, you might want to be there, actually. That's a really good talk to go to. But a lot of people who are really quite popular in the testing community and some people who are quite popular in the types community. And so not everybody had a ton of time. We put together several sessions, several working sessions to discuss how could we test the theory that you can TDD to well-typed code. And so Paul Snively and I said, okay, let's actually focus on this and figure out, is it possible, and do you want to do it? Is there value in doing it, or are you just going to waste your time? And so we said we want to be able to do the easiest thing possible, because we're both kind of lazy, so we don't want to do extra work. We don't want to charge our clients for extra work, right? And then we want to have solid code that has the least possible errors. And also, as I said earlier, we want to make sure that it's very readable. So we decided we're going to do some science. And the way we're going to approach it is to take a code kata. Has everybody heard of code katas before? This is the idea that you can write the same functionality over and over in different languages using different patterns, et cetera, to try and really hone your craft. And so we use this bank OCR code kata. So essentially you've got a bank account number, a 9-digit bank account number that is composed of these strings. So 4 lines with 27 characters per digit. So if you kind of stretch your eyes a little bit, you can see how we would have 4 lines across a 9-digit account number. And they're supposed to, for instance, this 1, 2, 3, 4, 5, 6, 7, 8, 9 would actually translate, the string would translate into the digits. Okay, and then there's a second story to this code kata, that we have a checksum calculation. And so you have the checksum to run to see, is this actually a valid account number? Okay, so what we did, we said, okay, we're going to use TDD, we're going to do unit testing afterwards, which is what most people at that time were actually doing when they said they were doing TDD. We were going to start with functional tests, encoding our functional tests. We were going to start with something called type signatures first, which is a concept that, that Michael Feathers has been talking about quite a lot, where you kind of hash out what all the type signatures would be, and then you just write the code to fill that. We tried the REPL-driven development thing. We tried the property-based testing. So property-based testing is something I've always thought of as something you do after the fact. It's not something that you don't TDD with property-based testing. Or so I thought. And then I ended up having some drinks with John Hughes, and he said, no, you should always be writing your property-based test first. Who's writing a property-based test first? Very few. So it's something that definitely check it out. It was a concept I hadn't heard of that I kind of made him work with me on to figure out, does this work? And then I tried this property-based testing afterwards. And I say I, but really what I mean is it wasn't just me. It was hundreds of code samples. At this point, it may be in the low thousands of code samples that a lot of the people in that room had either given to us or pointed us to. We used every language that we could think of. We used every pattern we could think of. And we also used GitHub. So who's done the bank OCR code kata before and put it on GitHub? All right, so none of you are going to see your code on the screen and be just horrified at this point. So we just did all of the analysis that we could from all of the code samples that we could find for this specific code kata. And we learned a few things. And I'm going to say, I'll call this analysis and not, this wasn't our findings. This isn't like, I'm not presenting to you a PhD thesis that I'm saying this is the way that it has to be. I'm just going to tell you some of the things that we learned along the way. The first thing that we learned is that it doesn't always have anything to do with types or tests. What is this code going to do? No ideas. Yeah, it's just going to match the digits. So, but when you look at the stuff on the left here, who wants to read that 6 months from now and say, what was I thinking? What was I trying to accomplish? Not me. So there are other language features that you need in order to make a really great language. And I think Paul actually pointed out first that was a feature of Scala that was really important, that he could just write these on multiple lines. And so I, of course, came back and said, yeah, but I could do it in F#. So here's just some example F# code for doing this kata. And so you can see there are different places where I used the type system. And then I used features like pattern matching, because a language without pattern matching makes it really hard, regardless of everything else that the language offers, the testing utilities, the types. if you don't have pattern matching, it's really hard to do anything. And so we use some types, pattern matching, and then the option type as well. And then moving on, also used a type of valid or invalid account, being able to say that the account is valid or not, and then be able to do something with that later, we found quite important. Something that I found really interesting, because I tried to come at this from the perspective, I was the TDD person since I was working for ThoughtWorks at the time, and Paul was coming at this saying he was the types guy. So really, we started out saying, we're going to come at it from different angles, the opposite angles, but that was false, because I came in this knowing that I really liked type systems. I've got ML tattooed to the back of my neck. I love it so much. Quite literally, the biggest shock to me was that there were types that I removed. I removed types because they made my code clunky. Who's done this in Scala? Who said, I'm going to make this super tight, well-typed, and then you had to remove some types because it didn't make your code super elegant? We've all been there, I think. It's one of those things that you feel a little dirty for, right? Because you're a little less safe. But the readability of the code in the end is really what matters. And so I think a lot of languages today put you in this position where you're writing code that's not that elegant in order to have safety. And this is where I think a lot of the Clojure or the Ruby developers are coming from and saying, well, I can read this. I'm always going to be able to read it. So we'll get into that in a minute. So tests validate what types are not able to prove. And this is kind of where I was coming from before when I said, well, the logic that's not really logic, the fuzzy stuff, you can prove all that stuff in tests. The stuff that your clients are saying it has to do this and it's supposed to work in this way. You can prove a lot of that stuff in tests, even if it's not mathematically correct. And then property-based testing, one of the things that we learned is that where you have a for all in your property-based test, you should probably have a type. I see some eyes widening at that statement. So tests help me to flesh out some ideas. Tests started, when I'm designing my code, I want to be able to flesh out an idea whether or not a design is going to work. A test is going to do that. Whether I'm making that a unit test or a REPL test, it's going to help me flesh out some ideas. But one thing that I learned quite quickly with looking at tons of code examples is that no matter who wrote the code, no matter what they were doing, the amount of tests was astronomical to maintain as compared to a type. So every line of code you write is something that you have to maintain, and it costs money to maintain code. We all know that. So if you have to maintain a line of test code, it's the same thing as having to maintain a line of application code. So I like to write the test to help me come up with the ideas, and then I like to delete them. If I can write a type that will basically do the same what the tests were trying to do, plus, right? It's giving me even more value than that. I like to encode anything that is for all into a type system. Okay, so what do you guys think of this code? This is some Clojure code that I found. And I started reading through it and I thought, oh, this is pretty neat. This is pretty readable. What's the first question that comes to your mind? Just when you look at it, you don't even have to read the code before it's like, whoa, what's that? What are all these numbers? They're magic. Where do they come from? Why are they there? What do they mean? And so my problem with this code was really just I have no concept of what they're trying to do here with all these numbers. So if I understand the problem and I understand the domain very well, then I can come in here and say, okay, well, I kind of get why they put those numbers in. But me 6 months from now doesn't want to read that. I don't want to have to figure out where the magic numbers come from. So types save me from thinking about certain categories of tests, which is quite nice. This is a lot of the stuff where people say, oh, well, I don't get the types of errors that type systems can prevent. I think that's generally false because they don't understand what they can do with a type system because they're doing string-based programming. And I think that the types prevent whole categories of tests that they hadn't even thought of and that they wouldn't write because they expect frameworks and languages to handle things for them. A really important discovery throughout this whole process was it's really easy to get lost and just kind of go around in circles over and over again in every language, using every framework, using every pattern, because you never have to deliver. So when you get the chance to do something like a kata, really take that for granted, or take advantage of that, and don't take it for granted that you're getting to do something that you're never going to have to deliver. I think code katas are really important. They come out of this Ruby world because people wanted to hone their craft. So I think if you get the opportunity to sit down and use katas, do it. Spend time with other people pairing and doing it, because it's great to have this experimental platform where you can never have to deliver. But syntax matters. This is one thing that I probably shouldn't do this at a Scala conference, but I will. This is Travis Brown's contribution to our project, where he said, okay, cool, I can encode the checksum in the type system. And there's some laughter here, but that's pretty sick, right? That's awesome. That's pretty cool. But again, me 6 months from now, me tomorrow. After a drink, I don't want to have to look at that again. It's one of those things I may not be able to pick it up very quickly. So let's be serious here. When you're talking about writing code that could be life or death, or that could be something that's going to cost or save the company a ton of money, this is exactly what I want to read 6 months from now. This is exactly what I want to have to rediscover over and over again, because of the value to the client. So syntax matters. Syntax is really important, and people aren't going to start encoding things into their type system until it's easier to do without having to strain your eyes to read. So I think that's a really important thing to keep in mind. What's the caveat here? Encoding the checksum for the account number into the type system. What's the caveat? Exactly. You can't do that at runtime. This is something that we changed the kata for our own purposes to say, what can we do? What abilities do we have in these languages? And this would have actually violated the kata altogether. Okay, so what do you guys think about this? This essentially does the same thing without the whole type safety thing. What do you think about reading that 6 months from now? Certainly we still have some of this magic number stuff, but that's pretty sweet. I could pick that up 10 years from now and know what I was trying to do. So having a language with a syntax that is quite great for encoding things in your type system, I think would make people care a lot more about type safety. So I haven't found, with all of the, literally, if you name a language, there's a very, very good chance that we did the kata several different times over in that language. I haven't found a language that makes Yarn Minsky's idea extremely feasible. Making illegal states completely unrepresentable is, yes, that's the holy grail. However, I think it's really important to make illegal states unrepresentable in situations that are high value to your client's code. So types, I think, scale a lot better than tests. I think tests are really important. I hope that I'm not giving the impression that I think types are better than tests. I think that they're both needed. I think tests are extremely valuable for documenting an idea of what were you trying to do. So if you have an open source system with no tests, I'm not contributing. Like, probably, a lot of people contribute, but that's just because they really like a challenge and they want to be that, that person who's really great at everything. I was going to say badass, but then I thought twice about it and forget it. That's what I meant. Small, short-lived code bases mean little value for types and great value for tests. Does this irritate anybody? So I've been having a lot of conversations with people like Jay Fields. He works at DRW, which is this. It's a financial firm where he puts code into production that's going to be like 5 lines of code that's going to be in production for less than a minute. That sort of stuff. He says if he would have to make sure that it was going to validate, the type checker was going to validate it, he wouldn't be able to write it fast enough to get it into production. Whereas he could just write a quick test, make sure it's going to do exactly what he wants, and then put it in production. Now, is that because he doesn't come from a background where this is something that he's done his entire life? Or is this because, it's just harder in the languages that are available for us? There's no answer to that question. It'd be really hard to come up with an answer. Even at the point where we say everybody's been learning the same stuff their entire lives, it'd be really hard to come up with an answer to that question. Types, for me, make it really, really easy to refactor because the compiler says no. Compiler says, no, I'm sorry, you've broken something. You have to fix that before you go to production. Whereas a test, I've only thought to write X number of tests. And I might not have thought about a way that something could fail. So I think types make it a lot easier to refactor. And types help me to modularize my code because it helps me to figure out where I'm putting which bits of code that are going to operate on which types. And so everybody, of course, when you start having this conversation, it's, oh, but it takes so long. SBT takes so long. Either the compiler is going to take a long time or the tests are going to take a long time. One way or another, you got to spend the time. It's just, do you want to spend the time up front preventing the errors, or do you want to spend the time debugging your code later because you didn't think of the test to write? So I like to write code just as it comes to my mind. You know, I probably had a lot of the same education as a lot of you guys, where I was learning to code with C-style languages, and then I wasn't really making heavy use of the type system when I was a young developer. And then I started to learn how to do it. So I will generally start to write my code in a REPL, just hacking out anything that works, string type programming, and then I'll refactor to types. So I think that there's probably something there, patterns for refactoring to types, that there's probably not a lot of great material out there on. So all type systems are not created equal. So why do people hate type systems? One word, Java. So all type systems are not created equal, but I think there are certain things that people need to have in a type system in order to make it extremely usable. And I'll also talk about the language features that kind of go alongside those to make it something that you can comprehend later. So some types, the inclusive or, this is your maybe, essentially. Either failure or success, some or none, et cetera, et cetera. That's awesome. Some types are fantastic. A language has to have that. And it has to have pattern matching, because if you don't have both, it's pretty much useless. Product types. So this is your ands. This is your records, your tuples, and your objects. And something that I think goes really well with that is currying. I think currying makes those product types valuable, because if you don't have that, then everything's a product type, essentially. Extensibility. I want to have the same tools to use when I'm writing my code as the language author had when they were writing the language. If the type system isn't extensible, again, this takes away a lot of the great value for me. So who knows what nominal and structural typing are? And so what's the difference between nominal and structural typing? You got lots of you raised your hand. Martin can't answer, I'm sorry. What was it? Exactly. So if you have booleans, if you give a type alias to a boolean, you call it X and then you call it Y. Can I pass in X where Y was intended? What's the safety mechanism you have here? The more specific your code is, the more structure, or the more nominal typing you use, the more safety you get. So type inference is another big thing that a lot of people say, oh, you just don't want to use type system because of type inference. Well, type inference is awesome, right? But type inference will infer the most general thing that will work. Whereas what you really want often is the most specific thing. So if you are using a type inference system that means that you don't have to write any of your types, then chances are you're not getting a lot of type safety. A lot of the stuff that you thought you were getting, you aren't. So this is like a big buzzword. Idris made dependent types this thing that everybody cares a lot about. The language on the screen is dependent ML. All it's doing is making sure that you can't zip lists together that are of different sizes. So dependent type systems allow you to do math within your type system. Turing-complete type system, pretty cool. And then this is the Idris example of being able to say that your vector of size n and your vector of size m, when added together, is going to be n plus m. So you're actually doing math in your type program, type level programming, which is pretty fabulous. So I have some final thoughts here. It's not really two sides of the same coin. I feel like it's more of a spectrum. Where you fall in the types and tests spectrum should be dependent upon the code that you're writing, upon the value of the piece of code that you're writing. So I think if you're ever in that bar argument, which I'm in all the time, where you're having to say types or tests, I hope that you'll stop the argument, you'll stop the people who are ready to fight and say, well, listen, it's really a spectrum. I want to use types and tests. And I think a lot of Scala developers really get that. They really understand the value of using both. And hopefully you now all understand why there's value in using both. Types is for all. Tests is there exists within logic. Please, please, please use the facilities that are available to you in the language. If you guys are writing Scala and everything's a string, go through your code, the code that you're writing today. Start looking through it and say, how many strings do I have? Is everything a string? Because if so, you're using Scala in a way that you're not really getting any of the advantages of the type system. So use the facilities that are available to you. So what does the future look like? I think it was Tim Sweeney who said that future languages will make type-level programming indistinguishable from the rest of the code. So as anybody who has written Haskell knows, that if you're writing code that looks completely different than the stuff that you actually wanted to do, that's the type system. That's the type stuff that you wanted to do. When we get to a point where you can write that all in the same language and not have to change the way you're thinking drastically, then I think more people will make use of the type system. And so I think that would be the perfect world where we get the most value per character that we type. So there are lots of open questions. Where does simulation testing fit in? This is what Clojure people are talking about now, where they provide a beginning database, and then they provide all of these characteristics about what the system's supposed to do. And the output is actually another database that says here that you can make assertions about. So your output database and your input database with all of those, all of the factors about what your code's supposed to do, how does that fit into all of this? I think it will provide extra safety. It'll provide a little bit of the extra stuff that the Clojure developers aren't getting now because they don't have a type system. And then mutation testing. I think mutation testing is a really interesting concept because what it does is it takes all of the tests that you wrote and all of your input code, changes your code, your system code, and says how many of your tests fail. Because if you're able to change the code and you have 100% test coverage with unit tests, then if none of your tests are now failing, or very few of them, that means that you probably didn't do a very good job writing your suite of unit tests. So finally, here are the 3 key takeaways. Please remember these things. If you remember nothing else, even the slide with the tortoise, remember these 3 things. If anybody would like to contribute who has done the bank OCR kata before, or who would like to do it now and do it in different ways, or see some of the code that we've put together or collected, then I'd be glad to work with you. So please contact me. I'm Pandemonial on Twitter. And this talk definitely would not have happened without Paul Snively, Paul Types, who's recently back to Twitter. He dragged me into doing this experiment based on the fact that I think I was annoying him with too many questions. So he's like, let's figure it out. So holler to Paul Types as well. Any questions?
Hi. Fantastic talk.
Thank you.
I agree with almost everything, I think, actually.
Hence the question.
Well, not really. This is more of an observation than a question. So you gave earlier on in the talk a couple of slides of what do types do for you, what do tests do for you, and I thought there was one, at least subjectively, really important thing missing from the type slide that I'm not convinced that you could actually find an analog for on the test slide.
Okay.
And on the type slide, and I think a lot of the complaints against types are that types are very focused on compiler says no. Compiler prevents you from doing certain kinds of things. When I'm working on the stuff I do in Shapeless, which is almost entirely types, it doesn't feel to me as though the compiler is saying no. It doesn't feel as though the types are stopping me from doing things. It feels as though the types are actually enabling me to do things that I wouldn't possibly be able to do any other way. And that the compiler, rather than saying no, is actually saying not here, but try over there. it's kind of pointing me in the right kind of direction. And that I feel is something which it's kind of selling types short, not to flag that up. And maybe there is an analog on the testing slide, but I'm not quite sure what it would be.
So I think what I hear you saying is it helps you figure out how to organize your own thoughts into the logic in your code. So essentially, it tells you can't do that here, but you may want to do it somewhere else.
That's part of it, yes, definitely. But also there's types as an enabling thing. A lot of what I'm doing, I suppose, is kind of sort of anticipating things I might be able to do an awful lot more easily in Idris, for example. But there is computation going on in the type system. Types are actually doing stuff for me, and that's not something that's obviously visible in the testing case.
Yeah, I think you're absolutely right. I'm trying to think about how you may put that. How do you put that in words that somebody who doesn't understand them will understand? I think that's kind of one of the hard parts for me about doing this talk and doing the experiment was how do I take something that I kind of get in certain ways. Certainly I learned a ton by doing the experiment, but I came at it from a perspective I already kind of got some of it. And how do I present that to somebody who doesn't? Like, how do you give that to a Ruby developer or a Clojure developer and say, here's what you're missing out on, without creating this whole elitist thing? Because I'm trying, the one thing, if I can do anything in this, it's to get away from the elitism, get away from the idea that I know words that you don't, so I'm better than you. Because I think we have that problem in this industry. I think a lot of us do it without even thinking about it. I know I do, and I did, and now I'm trying to step away from it. So I think I want to follow up with you on that later and see if we can figure out how do we phrase that? How do we put that in words people could get?
So it's half a remark and half a question. So Alan Perlis once said that Lisp programmers know the value of everything and the cost of nothing. And
okay.
I think that some of in Scala we see some of the same things emerging, because I think a lot of these questions are really a question of cost and benefit. Let's say detailed types is definitely a cost. It's a cost in readability. It's a cost in just the bulk of the notation I have to write, and there's a benefit. And generally there's a law of diminishing benefits. That means the more you put in, the less the benefit there is at a given technology. So I think, given that, would you agree that it's essentially all a matter of essentially the scale you want to go to, and that it's simply a matter of cost and benefits, and that's basically the point you want to make?
Absolutely.
Yeah.
And so that's one of the things that I was trying to point out is that there is, think about what you're doing. Is this valuable for your client? And I try to phrase everything from a consultant perspective. Even if you're not in consulting, pretend you are. Pretend that every line of code you write you have to pay for, or your most expensive client has to pay for, and understand it's a trade-off. There's cost benefit.
And the other question was that one thing you didn't mention at all was contracts. So essentially, require, ensure, assert in Scala. Is that that strikes me as something that combines some of the benefits of both tests and types, in that it's definitely very readable. And so, for instance, I would have done the checksum immediately with a contract. Of course,
right.
I would have put an ensuring in there.
Yep, this is one of the things that it didn't come up when we were doing the experiment. It never came out. Nobody was saying, oh, you need to be doing the contract stuff. And that probably comes from the space of, this is a kata, that a lot of people probably, it wasn't the new hot while people were doing this kata, so people weren't talking about it. So that is definitely an area that I should have put in the completely missed topics, for sure.
Mm-hmm. Thanks.
Other questions? Go ahead.
So, the question came up when I saw the Idris code, where you could do more complicated stuff in time. So my question came up when I saw the Idris slide about doing more complicated things in the type. And then I thought, do types only work if you do very simplistic functionality in the type? Because otherwise you would have to test the complexity of the function in the type, if you know what I mean. So if you don't only do n plus m, but you do a whole function of things there, you would have to test that code.
Yeah, essentially you're saying that if you have a Turing-complete type system, who's testing the types?
Yes.
How do you test that your types are doing what you want?
Yeah.
And so there's the concept of if it compiles, it ships. If it compiles, it's doing what you want. But if you haven't tested that code, then how can you be sure? That's a really good question.
Okay. Well,
my best friend is a first grade teacher, and she told me once, I said, Katie, do they ever ask you questions that you don't know the answer to? She says, yes, I just tell them that's a really good question. Go research that and get back to me.
Right. But would you do like property-based testing in that case? Would you then still use something like a quick check type of?
Yeah, I think property-based testing could help. I think that, I mean, any type of testing will help that, right? I mean, you're just automating a test against the type system. Certainly any type of testing, unit testing, property-based testing could work here.
Yeah. Okay, thank you.
Other questions?
Thank you. So I really like the idea that you should sometimes put yourself as the stupidest person in the room and then ask question. So I would like to ask the question, because I really didn't get to fully one of the key points that I should have take away from the talk. So I will ask again. So why the for all exists for the test and types? Can you
Sure.
tell this once again, please?
So if in your property-based test, or if in logic you can say for all, then there is a very good chance that you should be encoding that in the type system. You could write a type you could have your type checker check that for all is true. So if you're saying
for all in the specification or for all in?
So yes, for all in your specification. If you're saying for all, then that generally means you can't write tests for all, right? Like you can with a property-based test, but you can't generate all of the tests for all unless it's some really basic thing. So if you can say for all, regardless of the language, regardless of the problem, you should be able to write a type that will signify that. And then you don't have to think about it every time you change your code, because you know that every time this is going to be true because it's encoded in your type system.
Thank you.
We can talk offline if you're interested.
One more.
Oh, I'm sorry. Your hand was up for ages and I just wasn't looking over. I'm sorry.
This is more, I guess, an observation than a question. So the Ruby test code, where you said that reads quite nicely, which I agree it does. The downside of that is that the user of the library has to read that code to know, for instance, that it's because it's Ruby, that it's actually expecting a string as opposed to a number.
That's very valid. I think that there would have had to have been a lot more tests around that, and I think that essentially this is a test, right? If you don't read the tests, then you could pass a number to the function. But essentially, they've probably ensured that in other places in their code, it's only being called by X, Y, and Z. You're absolutely right. There's tons of tests like that you could write that people don't, because they make sure in other ways in their code by understanding the entire code base in their head at any given time.
And the beauty of a type is that it would have prohibited somebody from accidentally passing in the number, a number for the string.
Absolutely, but if you're in that bar conversation and you mention that guy's punching you, really. That's the type of stuff that makes people really angry.
Then we need a type check to keep them from punching us.
Yes. No, you're absolutely right. So I did definitely not show anything that would be a test that is exactly, are you passing a number or are you passing a string? Was there a question over here?
Oh, yeah.
Okay. Sorry.
Thank you for that. So, for instance, if you would say for all test if the number is prime, you say, no, let's build a type that defines a prime number, but that would be a tough problem, right?
It's not unsolvable.
Let's hope so.
Cost benefit. You're absolutely right. There's cost benefit, and this goes back to what Martin called out explicitly. Miles wants to answer that.
So this fantastic thing. It's kind of something that David Christensen put together. He presented a post on it at ICFP last year, and it's basically it's something fascinating. And I'm sure you and Paul have lots of fun following this up. It's kind of combining combining tests and types in a really, really interesting way. So Idris, because types exist as values, it has a very, very straightforward ways of exposing sort of general forms of computation as types. So what David put together was a form of, if you like, a type provider, which essentially provides types via performing quick check style tests.
Yes,
so
yes.
in particular, you can in effect delegate the role of prime testing to a very, very efficient value level prime testing engine, and have that extruded into your program as a type, which you can then use for checks and continue and continue the properties of your program on that basis. So
yeah.
it can be done. It's not just, there is active work on doing this kind of stuff, and it's definitely possible. It's very interesting.
I think this is a research space that's pretty active right now. I think super interesting. Idris is something a lot of people are passionate about. I don't know if Idris is production ready, but it's definitely research ready. You should hopefully be playing with it in your spare time, because I think you'll learn a lot of the things that you can't do in other languages, that then there'll be lots of pressure on other language authors to try and do that sort of thing. I love all the discussion. I feel like this is the type of room I wanted to be in when I was doing this research. So like I said, if you guys have any interest, I would love to have some contributions from people who are thinking in this way. Yes, I like that. But you haven't been to testing conferences seeing the same conversation. Doesn't end well.
Well, it's just a quick comment to complement what Martin said earlier, that you have a slide where you say that you should not allow invalid state to be representable. And then you showed how to use the type system to encode constraints and how this can get really complicated very easily. And one way around that is to annotate your constructors with preconditions. So then, even though you're not encoding the type system, the restrictions itself, you will never allow an instance to be created that is invalid. So I think it's a good trade-off between the full power of encoding your constraints in the type systems, but at the same time, not allowing invalid states to be represented.
Absolutely, and there are several different things that allow you to do just that. People are working around the problem because the problem is really hard. So I think kudos to the people who are working around it, and let's use those facilities to keep us safe. But also, I just want to make sure that we're still focused on future languages that are doing exactly this. Because if you do make the type level programming indistinguishable from regular code, then people are going to do it, and you're going to get tons of value. But the upfront value is there in creating languages that do this stuff.
Now, if you don't mind me asking a question more at the personal level, I read your bio.
This is an awkward moment.
No, not awful, of course not.
My husband's in the room.
Very respectful. I read your bio on the site, and I just found it fascinating that you mentioned things like you had punch cards from your grandmother, and then your father you learned to use Morse code from your father. I have a daughter, she's 2, and really I look forward to teaching her Scala.
Can I tell you the secret? The secret behind that is that I'm one of 4 kids. I'm the 3rd daughter. My dad really wanted a son more than anything. He came the year after me. So my sisters had no interest in math whatsoever. And so I wanted my dad's attention, because there's 4 kids. You don't have a lot of your dad's time at that point. And so in order to get his attention, I was doing math and ridiculous types of, I was programming when I was a kid just to, so the key here is to ignore your kids.
I was just going to say, so you're suggesting that I have 3 more daughters. The best way to get my daughter interested in software development is to have 3 more daughters then.
Yes, have lots of daughters, and you won't have enough time.
My wife is going to love this advice.
Oh, thank you guys so much for coming. I'll be around for the rest of the day.